Scientists try to investigate the object in space, such as stars, and for example, this is a galaxy, billions of stars into it. So they apply different techniques involving the light emitted by a star or a galaxy. So when they obtain the spectrum of the light emitted from a star or a galaxy, they get following these two patterns. These two patterns are there. So these two patterns are very important in order to study the nature of the star. So these two patterns shows this number one pattern and number two pattern. These are known as emission spectra. So you know about them in previous lectures. So for example, this star is a sun, and this is the energy received on the surface of the earth. Then when you obtain the spectrum of the energy released by the sun and received by the earth, you obtained the first one. So here you will see that it has two parts, left hand side and right hand side. So on left hand side you will see that there are blue lines, and right hand side there are red lines. But when you receive the light received from a distinct galaxy, very far away galaxy, and here is the earth, and when you analysis or obtain the spectrum of this light, then there was a strange thing. So two changes were observed. Number one, the lines were shifted towards red. The lines were shifted towards length, and there was increase in wavelength. So there was increase in wavelength, and lines was shifted towards red. In order to study the nature of the distinct star or stars or galaxies, the scientists take help from emission spectrum. And in emission spectrum, they started with Doppler effect. Doppler effect in AS level, you know that the apparent change in frequency or wavelength of the radiation from a source due to its relative motion away or towards the observer. So Doppler effect we can study on Earth, yani we can observe on Earth or in space. On Earth, Doppler effect of sound, and in space it will be Doppler effect of light. So Doppler effect of light in space we can study by study the emission spectrum or emission spectral lines. This emission spectral lines can be divided into two types. First is redshift and second is blue shift. Okay, redshift means, for example, here is an earth and here is an object such as star, and it is moving away from the earth. Blue shift means here is an earth and here is an object, and that object is moving towards the earth. Redshift means the fractional increase in wavelength or frequency due to the source and observer receding from each other. What will be its formula? As we know that there is a change in wavelengths, so we have to write delta L over lambda is equal to delta F over F is equal to V over C. What are these quantities? Change in wavelength. What is it? It is original wavelength. Change in frequency. And this is original frequency. And what we have, recession speed. V is recession speed. And what is C? C is speed of light. Speed of light. An expanding universe now. Okay, when redshift was discovered, then the astronomer realized that the space between Earth and a galaxy is expanding. So if you have here Earth and here is a distant galaxy, and this is the space between them. So they said that according to redshift, the light received at the Earth's surface from a galaxy, it is stretched. Light wave stretched. It means its wavelength increases. So the galaxy is moving away from us. So if redshift is greater, you know that delta lambda over lambda V over C. So if you are getting this ratio greater, it means speed of the recession speed of the galaxy is faster. It is moving at a faster rate away from the surface of the Earth. And this you can see from here. See here, this is the original balloon, and as soon as you blow air into it, then what will happen? The size of the balloon start to increase. These dots on the balloon represents the galaxies. So you will see that in first space there is a less space, and in second figure there is a more space. So this is the best example of an expanding universe. Consider here we have Earth and here we have a galaxy. Let d is the distance between Earth and a particular galaxy. So if it is moving faster, it means the distance will increase at high rate will be high. And if galaxy is moving slow, then distance increasing at low rate. So this shows that the recession speed of the galaxy and the distance between Earth and the galaxy, they are directly proportional to each other. And this is known as Hubble's law. So according to Hubble's law, the recession speed of a galaxy is directly proportional to distance between Earth and the galaxy. So here we have to write a constant of proportionality H naught d, and this what we call Hubble's constant. This is Hubble's constant, or rate of expansion of universe. Rate of expansion of universe. If we would like to plot a graph between recession velocity and the distance, we will get a straight line. So these are the galaxies which are near to the line, and these are close to the Earth. Why? Because they are moving at a slower velocity. And these galaxies are more distant galaxies, yani they are further away from the Earth. Why? And they are moving at faster velocity. And gradient of this line, if you would like to draw the gradient of the line, then it will give you velocity over distance, which is Hubble constant. So according to this speed of the galaxies, that is they are moving away from the surface of the earth, so it was believed that in the past there was a single point, and we call it singularity. Inside this single point, the mass and energy was assembled together, and due to a known reason, a big explosion happened, and the whole universe is divided into small parts, and they start moving away from each other. So figure on right hand side shows a big bang theory.